Good evening, my YouTube viewers. In this video, what we're going to do is we're going to do a practice question on proportion estimate. And the practice question is, in a survey of 200 students, 120 said they prefer online classes to in-person classes. Estimate the proportion of students in the population who prefer online classes and construct a 90% confidence interval of the proportion. So we're going to write a program in Python to answer this question. And the first thing that we're going to do is we're going to import the libraries that we're going to use to execute the program. So we're going to import NumPy as NP, which is the numeric library. We're going to import matplotlib.pyplot as PLT, which is the visualization library. And we're going to import from scipy.stats, we're going to import norm. So norm is like a normal distribution. Stats is the statistical module in SciPy. And SciPy is Python's scientific library. Then what we're going to do is we're going to define our variables. So you have a sample size of 200, you have successes of 120, and you have a confidence level of 90. Now we're going to calculate the sample proportion and standard error. Sample proportion equals successes divided by sample size. Standard error equals the square root of sample proportion times 1 minus the sample proportion divided by sample size. And now we're going to calculate the critical z-value for a 90% confidence interval. So z-critical equals norm.ppf, and ppf I think is percentage point function, brackets 1 plus confidence level divided by 2. We're going to calculate the confidence interval. So the margin of error equals z-critical times standard error. The lower bound is sample proportion minus margin of error, and the upper bound is sample proportion plus margin of error. And then we're going to print the estimated proportion and the confidence interval. So the estimated proportion is 60%, and the 90% confidence interval is 54.3% to 65.7%. So we're going to generate our x values for the normal distribution curve. So x equals np.linespace brackets sample proportion minus 4 times standard error, comma, sample proportion plus 4 times standard error, comma, 1000. I just want to check something here. So y equals norm.pdf, that's probability distribution function, brackets x, comma, LOC equals sample proportion, comma, scale equals standard error. So we're going to plot the normal distribution. So plt.figure, brackets, fig size equals 6, comma, 4, then plt.plot, brackets, x, comma, y, comma, color equals blue, comma, label equals sample distribution. So we're going to highlight the confidence interval on the curve by giving it vertical lines. So plt.axbline, brackets, lower bound, comma, color equals green, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals lower bound. And then you have plt.axbline, brackets, upper bound, comma, color equals red, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals upper bound. And then you have plt.axb line brackets, sample proportion, comma, color equals purple, comma, line style equals dashed, comma, line width equals 1.5, label equals sample proportion. So we're going to add labels and title and a legend to your graph. So the title is 90% confidence interval for proportion of a normal distribution approximation. X label is proportion, Y label is density. You're going to get a legend and you're going to get a grid, and then you're going to show it. So 90% confidence interval for proportion of normal distribution approximation. So you have the blue line is your sampling distribution, and it is a normal distribution. The green dashed line is your lower bound at 54.3%. The red dashed line is your upper bound of 65.7%. And your sample proportion is 60%. But it would be easy to calculate the sample proportion. You could do that in your head if you wanted, because 120 divided by 200 is 60%. But you do actually need to know mathematics to calculate the lower bounds and the upper bounds. And the good thing about Python and the good thing about SciPy in particular is that there are functions in Python and SciPy in particular, that enable you to calculate this so you don't have to do it by hand. So that's one of the fantastic things about learning statistics in Python. So that concludes our video. The next video is going to be on variance estimation. So I hope you decide to watch it.